Hi, Mrs. McTaggart here. In this video we're going to look at the higher maths topic of quadratic theory, and we're going to look at completing the square. So prior knowledge you should be able to complete the square already at National 5, where your trinomial is in the form of x squared plus x plus a number. Today we're going to be looking at ones with negative x squared and with a coefficient in front of the x squared, so it's going to get slightly trickier. So what I've done is I've kind of broken my examples into the three styles of questions. So my first two are going to be looking at ones with a negative x squared. So we'll start with them. So the method is here in green. What we are going to do for each of these, we can't complete the square unless it's in the normal format with the x squareds first of all. So what I'm going to do first is I'm going to rearrange these so that you've got the negative x squareds at the front. So we've got this. What we're going to do is we're going to remove a common factor. So this bit here says remove a common factor of -1 from only the x terms. Now some teachers will tell you to take the common factor out of all the terms, and that's perfectly okay. I only take it out the x terms because I want to try and avoid fractions as far as possible. So what we do now is we're going to divide the first two terms by -1, and we don't put it into curved brackets because when you're doing completing the square you'll have curved brackets, and too many brackets that look the same get a bit confusing. So when we take out a common factor of -1, I use square brackets, and that turns that into positive x squared, negative 6x. I close my square brackets and I'm going to leave that plus 7 at the end. So this number, the coefficient, the 7, just stays as it is right to the very last line of working. So now that I've taken out a common factor of 1, I'm going to look solely at this bit inside the bracket and I'm going to complete the square on that. Now you're used to completing the square on a trinomial. There's only two terms here, but the method's still the exact same. So you have your bracket and it's going to be x take away half of the 6 is 3, so it's x take away 3 all squared. Then whatever this number is in your bracket, so in my case it's 3, you take away that number squared. Now my class sometimes can't remember whether it's to add 3 or take away 3 squared, so I'm telling them it's always to take away. And the reason that is if I quickly go to the side, if you were to expand that bracket, that gives you x squared minus 3x twice over. So minus 6x plus 9. So the reason we take away 9 is to counteract that plus 9 so that these two things here look the exact same, right? So we need to get our expanded version to turn back into the x squared minus 6x. So it's always take away your number in the bracket squared, okay? So it's a take away 9. And now that I've done that, I can close my square bracket. I'm done with that bit. I've completed the square. And then the plus 7 goes on at the end. The last bit to do is I'm going to reintroduce that -1. So -1 multiplied by the bracket just gives you negative of your bracket. -9 becomes plus 9, and then I've got that plus 7 at the end. And the same with quadratic completing the square at National 5. The last thing you do is add the end numbers. So to tidy this up, you have negative of your bracket and then a plus 16 on the end. Now, I'm perfectly happy with my class leaving it at that stage there, but what you might notice is sometimes in the textbooks or in an exam, it might tell you to write it in a slightly different form. What they sometimes have is they just rearrange it so that you've got the positive thing at the start. So you might see it written like that sometimes instead. Be aware that's just the exact same thing. They've just switched the bracket and the 16 round in order because it looks a bit nicer. Alright, now why do we do completing the square anyway? The reason we complete the square in maths is to get the turning point. So if I asked you for the turning point of this, I'm going to go back to my second last line. The negative in front purely tells us that this is a sad face shaped quadratic. So it's going to be one like that. So it's a maximum turning point. And this occurs at -3, tells us that it's moved 3 in the positive direction. So remember, my trick is to tell you it's just the opposite of what it says in the bracket. So the turning point is along 3 and then plus 16. So along 3 up 16. And that's what you have there. Now, it doesn't always ask you for the turning point. Sometimes it just wants you to write it in the form. I've done it. But be aware, my blue answer there is sometimes the order they want it written in. Not always, because the previous line, this one here, is where I would prefer to stop, because that's where you can read your turning point off from easier. Right, let's look at the same next one. So we're doing the same again. We're going to rearrange it into negative x squared, negative 2x, positive 8. We're going to remove that common factor of -1 from the first two terms. So that makes that positive x squared and positive 2x. And keep that plus 8 running down the outside till the end. So I'm going to complete the square inside the bracket now. So x plus half of 2 is 1. So x plus 1 all squared. I take away 1 squared, so I take away 1. Don't forget to close your bracket, plus 8 on the end. Now we reintroduce the common factor of minus 1, so that gives you negative of your bracket. That turns into plus 1, and then you've got your plus 8 on the end. And the last step is you can tidy up the plus 1 and the plus 8. So you end up with plus 9. And just remember what I said is they might want that in the form 9 minus your bracket instead. And if I was asking for the turning point, this has also got a negative in front of the bracket, so this is also a maximum turning point. And the turning point plus 1 means it's going in the negative direction, so it's going back to negative 1, and then it's going up 9. Okay? And you could also know it's a maximum turning point back from the very start of the question. If I give you it in that form, it's a negative x squared, and we should know that as an upside down, a smiley face. An upside down parabola, that's what I was looking for. Right, so that's the first style. The next style doesn't involve negatives at the front, but it does involve a number. So my method up the top is with ones with an a in front, so a is just a number, remember. So ones with a coefficient in front of the x squared, your method is we're going to remove that common factor, and the common factor is just whatever your number at the front is, because completing the square is easy when it's on a single x squared term. So in the first one, it's a common factor of 3 running through the 3 and the 12. I don't remove the common factor from the 5 because it gives me fractions. So our first step is to do a 3, then square bracket, divide the first two things by 3, so that leaves you with x squared, minus 4x. Close the square bracket, plus 5 just hangs on at the end there till the end. So inside we're going to complete the square. So you have x, take away half of 4 is 2, all squared. Take away 2 squared, so we take away 4. Then we can reintroduce the number 3. So you have 3 bracket, x minus 2 all squared. 3 times 4 is 12, so minus 12 plus 5. And then when you tidy this up, you have minus 12 plus 5 on the end is minus 7. And if I was looking for the turning point of this one, this is a smiley face. So this is a minimum turning point because x squared is positive. So this is a minimum turning point. Minus 2 means it's going to positive 2. Minus 7 means down 7. So that would be your turning point there. Let's do the same again the next one. So you do common factor of 4 out the first two terms. Leaves you with x squared plus 2x. And your minus 3 just goes on the end. Complete the square inside. So you've got x plus half of 2 is 1. So x plus 1 all squared. Take away 1 squared, which is 1. Don't forget your minus 3 on the end. Let's reintroduce the 4 now. So you've got 4 bracket. 4 times the negative 1 is minus 4. And then you've got your minus 3 to do at the end. So when you tidy that up, minus 4 minus 3 is minus 7. And again, this has got a minimum turning point. Plus 1 means it's going to negative 1. Minus 7 means it's going down 7. So they both happen to be a minus 7 on that case. So this is your dream style. This is the style I want my class to always have, where it's simply a common factor. However, we're going to put those two steps together now. We're going to do one where it's a negative and it has a common factor of a letter. We're also going to look at ones that whenever I took out the common factor, I still had numbers that halved easily. What happens if that number, when you half it, isn't a nice whole number? So I'm now going to have a fraction. So question 5. It's positive x squared, so it's already in the layout I like. So step 1 is we're going to take out that common factor of 2. So 2 square bracket leaves us with x squared minus 5x plus 3. Now, when you try to do this bit, x take away half of 5, well, I'm just going to leave that as 5 over 2, all squared. I then want to take away 5 over 2 squared, so I'm going to go to the side. So remember that 5 over 2 squared is the same as 5 over 2 times 5 over 2. So you've effectively, you square the top line, you square the bottom line. So that gives you 25 over 4. Okay, so I can take that away because I need that space. So there's okay to go do fraction work at the side of your page. So taking away that squared leaves us with 25 over 4. Close your bracket, stick on the plus 3. Now I'm going to reintroduce the number 2 here. So it gives you 2 times your bracket, all squared. Right, when you double quarters, it turns into halves. And again, if you're not too sure, write it like this at the side. And if you were to multiply that, that would give you 50 over 4, which then just goes to 25 over 2. So effectively what's happening is you are basically halving that bottom number when you're multiplying by 2. So the bit that you then take away becomes take away 25 over 2. So take away 25 over 2. Now at this point, see that plus 3? Because I'm dealing with fractions, I'm going to turn that into a fraction. Now if you're talking about halves, then 3 is equivalent of 6 halves. So 6 over 2. And it just makes that last wee step a wee bit easier if you've got it all in halves. So to reiterate what I just did, I turned that whole plus 3 into 6 over 2. So I turned it into halves. And then we've just got to deal with the top numbers. Minus 25 plus 6 is minus 19 halves. Now this one, if I'm looking for the turning point, this is also a minimum turning point because it's positive x squared. And it just happens to be fractions. So that goes to positive 5 over 2 and negative 19 over 2. Okay. They're not nice, are they? Right, so my last one. This is a big deal. This is the one you're going to have maybe in an exam that's not really nice. It's got a negative. It's also got a common factor too. So the first thing I'm going to do is I'm going to rearrange it. So I'm going to rewrite this as negative 2x squared, negative 8x and plus 6. So I've just got it in the order we like. Common factor here will be negative 2. So if you divide this by negative 2, that becomes positive x squared. This will change. Minus 8 divided by minus 2 will turn to positive 4x. Please be careful with that bit, okay? So the sign changes and 8 divided by 2 is 4. And I'm going to leave the plus 6 outside. Now I can just follow the same steps as before. Let's complete the square. So x plus half of 4 is 2. So x plus 2 all squared. Then I'm going to take away 2 squared, so I'm going to take away 4. And I'm going to add on 6. Now, here's the tricky bit. I'm going to reintroduce that negative 2. So you've got negative 2 in front of your bracket. Negative 2 times your negative 4 turns into positive 8, then plus your 6. And to tidy that up is 14. And if I was asking for the turning point, this is a negative x squared one, so this one is a maximum turning point. And it would happen at negative 2, 14. Okay. So that's me showing you the 3 different styles, okay? So the negative x squareds, the ones where there's a number in front of the x squared, one where it could be a fraction, and then the bit where we put it together, where you've got a negative and a common factor. So there's plenty of exercises of these available online. What I've done though, my next slide, these are examples I would give my pupils, and literally what happens is I've split them all up, and I would say, right, this is like example 1 and 2, this is like example 3 and 4, and the others here are like example 5 and 6. So actually, these two here are like example 5, and this one is like example 6. So a slight change of order. So they're good ones to try. So if you wanted to do them, you could pause the video and give them a try. And then what will happen is if you then press play, you'll see my full work solutions on the next couple of slides. But there won't be me talking through them, so it'll just be the answers. Okay, thanks very much. Hope this has been helpful. Good luck. So there's your answers to the first 2. There's the answers to the second 2. There's your answer to the next 2, so the ones where you've got a common factor and a negative. And there's the answer to the final 2. Apologies that G actually turned out to be very like my example as well. Thanks very much.